The next question that we'll be trying to solve is maximum size of a set after removals. In this question, we are given with two arrays, nums1 and nums2. Okay, each nums1 and nums2 is of size n. Okay, and it is given that n is even. Now, what we are supposed to do is we are supposed to remove n by 2 elements from nums1. We are supposed to remove n by 2 elements from nums2. And after removing, we need to add the remaining elements of nums1 and nums2 into a set S. Right? After doing that, we want to make sure that our size of the set should be maximum. Okay. For example, if we have nums1 as 1, 2, 1, 2, we have nums2 as 1, 1, 1, 1. We can remove 2 elements from here, 2 elements from here, and then add the remaining elements into a set. So if we decide to remove 1 and 1 from here, and if we decide to remove 1 and 1 from here, then the remaining elements are 2, 2, 1 and 1. And if we add all these values into a set, we have only 2 elements, right? So the size of the set is 2 here, and if we take any other possibility of removing elements from this nums1 or nums2, we will not be able to get a set with more than 2 elements. Okay. This is the question. Looking at the constraints of the question say that our array length of n value, right? Our array is of size n, and n value is in the range of 1 to 2 into 10 power 4. It is also given that n is even. Along with that, it is also given that your nums1 of I and your nums2 of I is in the range of 1 to 10 power 9. These are the constraints of the question.
Okay. So before we solve the question, using a set will be like a prerequisite to this question. So in Java, we have hash set. In C++ and Python, we have sets as well, right? So sets will basically allow us to store unique elements in it, and we can do find operation on it in log n time, right? So we can store and find in log n time. Okay, and if you're using a hash set, then or an unordered set, then it will happen in just O of 1. Okay, so just having a good understanding of how to use that will help you in this question. Okay, now the first step we do is now this is basically nums1. This is the first array, and this is the second array. Okay, right. Okay, so let's just convert these both array values into sets. Basically, we'll just take a set of all the numbers present in this array. Okay. Now, a set means we'll have all the unique values, right? So 1, 2, 3, and 5. These are all the unique values. And in this, all the unique values will be 2, 3, 8, 7. Okay.
1 also.
And yeah, sorry, 1 as well. Right. Now, we have some unique elements here and some unique elements here. Now, let's take a third set that will consist of all the unique elements from both these sets. All right. So that third set will basically be addition of these both sets. Okay. So 1, 2, 3, 5, 7, and 8. Okay. This is the third set. Okay. Now, what we do is, now a lot of elements are repeating, right? So we have 2 here and we have 2 here as well, right? So when we want to make the final set by taking n by 2 elements from left and right both, if we take 2 from the left from nums1, and if we take 2 from nums2 as well, then in a way what we are doing is we are basically putting the same number again and again, right? But instead of taking that, what if we would have taken our number differently? So in that way, we would have maximized our answer, right? So what I can do is I can keep track of two values. Okay. First will be, I'll just call it value 1. Okay. This value will basically be all the elements that are present in num1 but not present in num2. Okay. So this can be easily found out if you iterate through this set. If you iterate to all the values in this set, we can just check for 1. We can check, okay, whether 1 is present in num1 and num2, and we can get that value. So value 1 will hold the count of the number of values present in num1 but not in num2. Okay. Now let's see for this case what will be that value. So basically 1, 2, 3 is also present in nums2, right? So here val1 will only be 1. Okay. And
what does val1 equal to 1 represent?
val1 represents the number of elements that are present in num1 but not present in num2. Okay. And in this case, there's only one element, 5, which is not present in num2. Okay. Similarly, we'll take val2. Okay. This represents the number of elements present in num2 but not present in num1. Okay. Here, basically, just 8 and 7. So, two values. Right. Now, the thing is, we will try to include the numbers, try to include these numbers as much as possible, right? Because we want to maximize our answer. So since we want to maximize the size of the final array, we'll try to include elements that are unique to num1 or unique to num2, basically, right? So from this, we can simply say that our answer can easily be val1 plus val2, right?
Yes.
As long as this value does not exceed n. Okay. Because
not exceed n.
Right. Because we are taking n by 2 elements from left and n by 2 from right. So after combining them, at max we can just get n unique elements, right? We cannot get more than n unique. So this value is for sure possible. So if it is exceeding n value, then we just say that n will be our answer. Okay. Now, besides these two values, there will be some other values as well, which are present in both num1 and num2. Okay. Now, the thing is, we can include these elements as well, as long as it's not exceeding the n value. Okay. So let's see what is the count of those values. Okay. So let's say we'll call it val3. Okay. Val3 is the count of the number of elements that are present in both the sets. Okay. Now here we have 1, 2, 3 and 2, 3, 1 here. So basically val3 will be 3. Basically there are 3 elements that are present in both nums1 and nums2. Okay. Our final answer will basically be minimum of val1 plus val2 plus val3, comma, n value. Okay. Right.
Why are we adding val3?
We are adding val3 because we know for sure we can add val1 and val2. Right. We know for sure val1 and val2 can be added, and val3 is the values that we can also add because they are present in both of them. So from any of them, we can add and eventually fill up the remaining places, right? So basically, in this this array was of size 6 and this was of size 6, right? So let's say I picked up 5 from this, and there are 2 other spots empty here, and from here val2 value was 2, so I picked up 8 and 7, and 1 spot was empty here. Okay, right. Now I just need I'm adding the val3 value because whatever the val3 value is there, 1, 2, 3, basically it's present in both the elements. So these 3 spots can always be filled, right? This can always be filled with those 3 elements. These can always be filled with those 3 elements. So basically there's always some way to fill these up, right? So I can just say 1, 2, and 3. I can fill this spaces up, right? And it's possible that in some cases, some places might not be filled if the val3 value is very low. Okay. And if the val3 value is very high, sometimes it might exceed the value of n also. That's why we put this check. Basically, answer should be minimum of val1, val2, val3. I mean, addition of all these 3, comma n. Okay. So this will ensure that it does not exceed n. Okay. let me just stress on what val1 and val2 represent here. Okay, val1 represents the number of elements that are present in nums1 but not in nums2, also ensuring that this value does not exceed n by 2. Okay, this value should be less than n by 2. If it is exceeding n by 2, then we will set it to n by 2 only. Okay, so what I can just say is whatever this value is there will always be minimum of val1 comma n by 2. Okay, and this will also be minimum of val2 comma n by 2. Okay, so yeah, this is how we solve the question, right? So let's discuss the time complexity. Okay, time complexity of this question will be O of n log n. It will be n log n if you're using like a ordered set. If you're using a hash set, then in that case we'll have O of n only, because in hash set the find and storing operation will just take O of 1, and space complexity will be O of n. Okay, O of n because we are creating two different sets for nums1, nums2, and a third set for nums. I mean, just a collection of both of those. Okay. So yeah, this is how we solve this question.